Let's find the molecular formula for a molecule that has more than two elements. I'll refer you to my other videos on empirical and molecular formulas for more examples. Caffeine is a stimulant found in coffee, tea, and chocolate. It contains 49.48% carbon, 5.16% hydrogen, 28.87% nitrogen, and 16.49% oxygen, all by mass. And it has a molar mass of 194.2 grams per mole. Let's determine the molecular formula, but first we'll determine the empirical formula, which is the simplest whole number ratio of elements in a compound. We'll first assume a 100-gram sample, which is convenient to convert the percentages into grams. The mass really doesn't matter to us. What does matter to us are the moles of each element present and how they compare. Use each element's atomic weight to convert to moles of each element. Dividing by the smallest moles and comparing gives the simplest whole number ratios of moles of elements in the compound. The empirical formula is C4H5N2O. Now we can find the molecular formula by finding the relationship between the molecular formula mass and the empirical formula mass. This equation has been explained in earlier videos. Briefly, we can multiply the empirical formula by the ratio of the molecular formula molar mass, which is given in the problem, and the empirical formula molar mass. Here, the ratio is 2. We can then distribute the 2 to get the molecular formula of caffeine, C8H10N4O2.